girls. This is our third lesson this week, and today we're finally going to look at our first chemical reaction. Okay, we're not going to use bases today, but we're going to look at acid. We've got quite a strong hydrochloric acid here, and I'm going to drop into it a piece of magnesium. So this is a chemical reaction between acid and a metal. Okay, so I'll just get a little bit. I'll need a little match here. Right. So here we go. Goggles on. Dropping it, and what you'll see straight away, quite a lot of bubbles. You can see this chemical reaction going on. There's some kind of gas released, and we're going to try and figure out what gas it is. So have a look at it. Okay, there's more bit of a fart in it. Okay. Try one more time. Okay. Right. You probably obviously saw that flame just got distinguished, and hopefully you heard that like a little fart that just escaped from somebody. What will happen if I had the right tube, which is a little bit bigger than this, it will actually make a pop. Rather than it should make a pop, a squeaky pop. And one of the things that we're going to do in this acid and base chapter, we're also going to learn how to identify gases. So the gas, guys, that was released here is hydrogen. The way to identify hydrogen is to put a flame, and the flame will create a pop, which is actually basically a mini explosion. We've got to create a small explosion here. Hydrogen is a very flammable gas. So metals inside acid will release hydrogen. Okay, let's write that on the board. Okay, so now we're back on the board. So let's try and find out theoretically what actually happened here. We had hydrochloric acid, we added magnesium to it, and we saw that the gas was released. We identified it as hydrogen. Okay? Now, there's something else. There was still liquid there. Okay, so some of the acid remained there, but there was actually something else. Now, if we look at that reaction, we should try and figure out what's the other bit that we have here. Okay? We've got the hydrogen. Where did the hydrogen come from? Remember, hydrochloric acid. In fact, every acid has hydrogen in it. Okay, so maybe I'll write down the symbol equation, and that will give us a hint. So HCl. So the hydrogen came from the H. Magnesium is Mg. Can you see this? It's big enough. Yeah. Mg. Okay. Now, if we got H2 here, right? We've got H2. That came from the HCl. Then what are we missing? Correct, we're missing the chlorine in the magnesium. So what the other element is magnesium chloride. Magnesium chloride. Yeah, you can see that. Okay, so now we can write down the formula or the symbol name for magnesium chloride. Magnesium chloride is made out of Mg and Cl. Remember, in our last week, we spent almost 3 weeks figuring out what's the formulas for these ions. Okay, ionic compound. Magnesium chloride is an ionic compound. It's what we call a salt. Okay, what is a salt? It's not just a salt that we eat. It's a metal and a non-metal. The metal gives electron. The non-metal receives electron. And we learned of this really clever way of deciding what will be the formula. How did we do that? We said, okay, Mg is 2 plus, right? Because it comes from column 2. Chlorine is column 7, okay? So it will be 1 minus. So the formula, we just do that cross method, right? We take the 2 from the Mg, we put it on the Cl. We take the 1 from the Cl, and we put it on the Mg, or we just don't write it. We shouldn't really write it. So the formula is MgCl2. Okay? So now you are able to predict what will be the products of a chemical reaction between metals and acid. If I take HCl plus magnesium, Mg, I will always get hydrogen every time. Every time I add metal to acid, I will get hydrogen, and I will get a salt. In this case, MgCl2. Okay? Now, there's one thing we haven't done yet. Can you think about that? What's wrong with this chemical equation? Okay? It's not balanced, isn't it? I've got 2 hydrogen, only 1 here. But let's just agree not to balance this point, okay? We're going to go through 3 types of chemical reaction in the next week or so, okay? Let's just not do any balancing. We will deal with balancing after we finished all these chemical reactions, and we're going to revise that. It's just going to make things too complicated if we start balancing every time. It's complicated enough, isn't it? Okay, let's make up another kind of chemical reaction. You see, the cool thing in chemistry is once you learn a certain pattern, then you can predict what will happen when you mix things you haven't mixed before. So let's mix the same hydrochloric acid. And hydrochloric acid. This time, instead of magnesium, let's give it calcium. Calcium is also a metal. No, let's not do calcium. Let's do something else. Let's do sodium. No, sodium. Yeah, let's do sodium. Okay. All right. So we're always going to get hydrogen. So it doesn't matter what metal you put in what acid, you're always going to get hydrogen. Okay? So that's the first thing you can write, hydrogen. You don't have to think about it. The second bit you're going to get is your salt. Okay? And what is a salt? It's not the salt you put on your chips. It's a salt that's made out of the metal that is hiding somewhere here and the non-metal which is hiding somewhere here. Okay? Alright? Now, for some people, they can just do it straight away. Others actually might find more comfortable to write down the symbol equation. So let's also write down the symbol equation. Hydrochloric acid, I'm still working with HCl. Sodium is Na. Okay? I'm really expecting you by now to know these symbols, right? We did that in grade 8. Now you really need to get it, okay? Hydrogen, no problem, H2. Now I got to think about, okay, I've got a compound here, salt, that is made out of a metal and a non-metal. What is the metal here? Where is the metal? Here we go, it's the sodium, Na, okay? So that's the metal. Now, where is the non-metal? The non-metal always going to be hiding in the acid. In this case, it's Cl. It's Cl chlorine. Okay? So the salt is going to be sodium chloride. Okay? It's not sodium chlorine, it's sodium chloride. We learned that also in that ionic compound. Okay, and now we can just finish the symbol equation. You need to be able to write a word equation and a symbol equation. So we've got H2. What is sodium chloride? Okay, it has Na and it has Cl. What will be the ratio between? Well, Na, I'm going to write it below, is +1. Cl is -1. So sodium gives 1 electron. Chlorine takes 1 electron. Okay? So if you just do the cross, it's just going to be NaCl. That's your salt. And incidentally, NaCl is actually the salt that we eat on chips. Okay? Right, I'm going to pause and we'll put some more examples. Okay, last 2 examples, guys. Now, we're actually not even going to work with hydrochloric acid. So let's say we took sulfuric acid, okay? And we added to calcium. Calcium is a metal, okay? So a metal and an acid, always, automatically, you can write down hydrogen. Always going to get hydrogen, okay? And then we're going to get a salt, okay? What is the salt? Let's just write down salt. Let's write it here, salt. Okay? Salt is a metal plus a non-metal. Let's try and figure out the salt this time without actually writing the symbol equation. So remember, the metal is the metal. That's the metal, okay? So that's going to be calcium. And then the non-metal hides inside the acid. Now, hydrochloric acid is the easiest acid to figure out because the chlorine is your non-metal. Sulfuric acid, okay? You might think that there's sulfur in it. You're right, there is sulfur, but it's not just sulfur, it's sulfur and oxygen. Okay? Let's write down the formula for that. Maybe it will help you. Okay? So H2SO4. We've come across that at some point. We spoke about that, I think, in the ionic compound. It's made of hydrogen and the ion called sulfate. Okay? That SO4 is sulfate. Okay? So your non-metal in this case is not just one ion, one atom ion, it's multi-atom ions, a bunch of atoms that form one ion together, as we saw in last week. So your non-metal is your sulfate. Okay? So the answer will be calcium sulfate. That's the ionic compound. That's your salt. Okay? Maybe I'll put some colors here. Okay? So we'll leave that as calcium. We'll write sulfate in red. Check this. So sulfate. And I'm going to put that in red as well. Sulfuric acid. Okay? So sulfuric acid plus calcium will give you hydrogen and a salt, which is made of calcium sulfate. Okay? Let's do the symbol equation. H2SO4, sticking colors now, okay, plus Ca gives you H2 plus, alright, CaN and SO4, okay, so we're going to have CaSO4. But remember, we need to figure out the ratios. It's not going to just be CaSO4. It might be, but it might not. How do we do that? We write Ca is column 2, so it's 2 plus. SO4 is 2 minus. Just got to remember that. Okay, that's part of that sheet that you need to remember. And the ratio is 1 to 1. I shouldn't take 2 here and put another 2 there. That would be wrong. That's just using the cross method without thinking. You got to also simplify. You simplify it. So ratio is 2 to 2 is the same as 1 to 1. Okay? Calcium gives 2 electrons. SO4 accept 2 electrons. So it's CaSO4, and I'll just put them a little bit closer. Okay? And we're not balancing. Complicated enough. Okay? We'll deal balancing later. Right. Let's move on to one more acid. Okay? Nitric acid. Nitric acid added to aluminium. What can we automatically say will be the first product without even thinking? Correct. Hydrogen. Okay. Hydrogen. I'll even write straight away H2. Now, what will be your salt? Salt is made out of a metal and a non-metal. Okay? The metal, here it is, aluminium. The non-metal, where is it hiding? Correct, in the acid, nitric. Nitric comes from an ion or multi-atom ion called nitrate. It's not just nitrogen, it's nitrate. Okay? You'll get it eventually, don't worry. I know it takes a while. We'll spend a long time on these reactions. We'll spend as much time as we need until you remember them. Aluminium nitrate. Okay? Again, for some of you, at least for me, it's easier to solve that first by looking at the symbol equation. So, nitric acid, it's one of those that you'll just have to remember, okay, is HNO3. We discussed it earlier in the week. You will remember it, don't worry. HNO3, aluminium, Al. Okay. I already wrote H2. Now, the salt is going to be made out of aluminium and NO3. Well, it's probably just not going to be just like that. Okay, there's going to be some kind of ratio that we need to figure out. Aluminium is from the third column. So what will be the charge? Correct. 3 plus. NO3, sorry guys, you're just going to have to, it's one of those you need to remember. It's -1. Charge is -1, okay? We discussed that last week. So if I do the cross method, I'll take the 1 here. For those that don't need to write anything. Put the 3 there. But of course, I'll remember to put brackets because I need 3 nitrates. Okay, guys? Alright. Have a lovely day. Enjoy your weekend. Okay, I've given you some work to do beneath this. You just need to write word equation, a symbol equation. So I gave you half a reaction, just not the products, but the reactants. You need to write the products, words, and write the full equation, symbol equation. No need to balance. Please put it onto your homework folder, and I'll see you guys next week. Enjoy your weekend.